Okay, review what we did last time. The variable of interest is x. And let x be the IQ score. Okay, x be IQ score. IQ score are normally distributed with mean equal to 100 and standard deviation equal to 15. For the notation I use, mu stands for population average or population mean. And sigma stands for population standard deviation. Okay. And let's try part E. Find the percentage. Find the percentage of IQ score that are 100 or more. 110 or more. Okay, the 100 or more. Now, to see this, we were told x follow normal. Normal distribution is a bell shape. Center at 100. And standard deviation is 15. Okay, so this is 115. Okay, 115. This is mu. This is mu plus what? Sigma. And we are asked to find what? IQ score is 110 or more. $110 or more is the size of the shady area. Okay, now find the percentage of IQ score that are 110 or more. Percentage. This is from what? Data point of view. Okay, for data point of view. So this P stands for percentage. And X IQ score is 110 or more. Okay, this is our expression. Okay. So how can we find the red shady area? Well, in order to use standard normal table, we have to standardize it first. Okay. Standardization. Standardization of a particular variable, it means you need to subtract its mean and then divide it by what? Standard deviation. After x, subtract by average and divide it by standard deviation. You're going to convert to z-score. Okay? So in our case, average is 100. Standard deviation is 15. So let's standardize 110. 110, the x-score, you subtract 100 divided by 15. What do you get on this number? Well, this number is 10 over 15, which is 2 over 3. If you run it to the close what? Number, to second decimals, you find the closest one is 0.67. Roughly equal, not exactly equal, okay? So this is the area we are looking for, okay? This is the area what we're looking for. Let me use red shady area, okay? Let me use the red shady area. Okay? And after you standardize it, this probability of this percentage observation x-score greater equal to 110, after you standardize it, you change to what? The standard unit or z-score greater or equal to what? 0.67. When you convert to standard normal, then you can go ahead, or we can go ahead to use standard normal table. And this is a way how standard normal table works, okay? It begins with z-score here, 0.0 row. Then you move down, you start when you see 0.6 row. And then you move on, you stop when the position intersect with 0.07 cotton. Okay? When intersect with 0.07 cotton. Look at here, 0.6 row plus 0.07 cotton. They add up to what? They add up to 0.67. Okay? This is a way how the standard normal table is designed. Okay? So let me show you the standard normal table in your textbook. Okay? This is a standard normal table. As what I just mentioned. Z begin with 0.0, you move down. You stop when you see 0.6 row. Then you move horizontally. You start at this number, 0.7454. Why you stop here? Because when you move up, you find this is 0.06 column. Okay? So together, this one return what? The size of the shady area from 0.67 all the way to the left. This shady area, its size is 0.7454, okay? It's 0.7454, okay? 0.7454, okay? That is this area, the blue shady area, 0.7454. And that is to say the blue shady area here, its size is 0.7454. And we know, okay, the area under curve add up to 100%. Why is 1? 1 means 100%. 100% of observation should be included, okay, under the curve. This is a basic one, principle. When you draw a curve, you need to make sure under the curve, cover all observation. All observation means 100% of observation. So if I tell you this part is what? 74.54%. How about its complement? This will be 1 minus 0.7454. Okay, that is to say the part we are looking for is 1 minus 0.7454 as well. Okay, so this one we can write as 1 minus the z-score. Okay, less equal to 0.67. And this will be 1 minus 0.7454. Okay, and this will be 0.2545. Now, usually, if from data point of view, we leave as a percentage. So we write 25.45%. But if this is probability, then we leave like a 0.2545. Okay? Okay, let's look at part F. The probability of selecting a person at random having an IQ score of 110 or above. Look at here, the probability of selecting a person at random. This is from probability point of view. From probability point of view, then we still write P, but this P stands for what? Probability. That stands for percentage, okay? Probability that a randomly select person, his or her IQ score is 110 or above. See, we use the same, exactly the same notation. That means if you follow the same steps as before, you're going to get the answer is 25.45%, right? But when you write percent, that means percentage of observation, okay? So this one is preferred. You write as a probability, 2545. This one is preferred. Usually, if you write this percentage, that means this P means what? Percentage of observation. But if you write like 0.2545, that means this refers to probability, okay? Now let's look at G part, okay? Let's look at G part. The percentile rank corresponding to an IQ score of 125. This is IQ score. We use X to denote the IQ score. And we know IQ score follow a normal distribution is bell shape. And the center of the distribution, the center of bell shape is 100. And here is the IQ score, 125. And when we ask you the percentile rank corresponding to IQ score of 125, what does that mean? That means we want to find the cumulative percentage up to this point, okay? Percentile rank is the cumulative percentage. Up to 125, okay? In other words, we want to find the size of the shady area, okay? We want to find the size of the shady area. How can we find it? As usual, we need to standardize this, okay? And how standardization works? Well, X subtract by its average divided by standard deviation. And we'll convert to z-score. Average is 100. Standard deviation is 15. So let's standardize 125. Okay? 125 subtract by 100 divided by 15. So this is 25 over 15. 25 over 15 is what? Is 5 over 3. And that is 1.67. Okay, roughly. Okay. So we try to find the size of the shady area. So let's see. The percentile rate corresponding to IQ score of 125. Okay. We want to find percentage, okay, of observation with IQ score less or equal to 125. That percentage is called cumulative percentage, and that's what we're looking for. So after standardizing, this is z-score, okay? Percentage of observation whose z-score less or equal to what? 1.67, roughly. Okay, roughly. So we got a second chance to use the standard normal table, okay? Now, please look at the standard normal table here. 0.0, you keep moving down. You stop when you see what? 1.6. Do you see 1.6? Then you move horizontally. You stop when you see 0.9525. Why you stop here? Because when you move up, you find this is 0.071 column. That's what we're looking for, okay? So let me repeat what I just said. Z-score, standard normal table. Begin with 0.0 row, you move down. You start when you see 1.6 row. And then you move horizontally. Then you stop when you see this number. Why you stop here? Because this corresponds to 0.071 column. 1.6 row intersect with 0.07 column. That gives you 1.67, okay? This is the way how table is constructed. So this one will return 0.9525. But in the test, okay, you can write 0.9525 or you write 95.25%. But this one is preferred because this is cumulative percentage up to this point. Okay,